Assalamualaikum and greetings to all. Today's topic is on chain rules. So here we have a function with multivariables, but there are variety of cases where you might have three independent variables, two intermediate variables, or vice versa. So we have many cases. I'm going to show you a few cases. All right, let's look at the first case where we have two intermediate variables and two independent variables. So here we have a theorem. If z is equal to f of uv, u is equal to g of xy, excuse me, and v is h of xy, and the partial derivative of f, g, and h exists, then partial z partial x is equal to this, and partial z partial y is equal to that. Okay, I don't recommend you to memorize this. I will show you the technique where it will be easier for you to get what is partial z partial x and partial z partial y. This is called a tree diagram. So it's better if you form or plot a tree diagram. Okay, for a tree, usually you start at the bottom and then you go up, but my tree is a bit different. I'm going to start from the left and then going to the right. Okay, let's see here we have z. So z starts on the left. So z is a function of u and v. So from z, we branch out to two branches, u and v, because z is a function of u and v. Okay, now next line, we have u is equal to g of xy. So from u here, it branch out to two branches, because it says u is a function of x and y. And then here we have v is a function of h, is equal to h of xy. So v here is a function of x and y. So from v, this branch here, it will branch out to another two branches, x and y. So now when you look on your far left, we have z here. Z is what we call the dependent variable. So z here is the dependent variable. Now when you look on the far right, okay, on the far right, we have two variables, x and y. So here we have two x's and two y's. So x and y are what we call the independent variables. And in the middle here we have u and v. So u and v is what we call the intermediate variable. Okay, so u and v are called the intermediate variable. Okay, now to get partial z partial x, so since the independent variables are more than one, so in this case we have two, so when we differentiate z, it's gonna give you partial derivative because we have two independent variables. So let's say you want to find partial z partial x. Now when you look on the far right, we can see that we have two x's, one here and one here. So what should come to your mind is we should have two terms. It's going to be sum of two terms because we have two x's on the far right. Okay, now let's find the first term. The first term is where you want to go from this z to this x, but you have to go through u first. Okay, so we have from this z to this u, it's going to be partial z partial u. And then from this u to that x, it's going to be partial u partial x. Okay, for the second term, we go to the second branch of x here. So to go from this z to that x, it has to go through v first. So the first branch is partial z partial v. And then from v here, we have partial v partial x. Okay, this one looks like, hang on, doesn't look like a v. So let me rewrite that. So this is partial v. Okay, so we have two terms. So, well, you don't have to write the boxes there. Okay, the reason I'm writing the box is to show you that we have two terms. Okay, so you don't have to memorize the formula here. You just get the formula from the tree diagram. Okay, now let's look at how to get partial z, partial y. Okay, let me erase some of this. Okay, for partial z, partial y, we look at the far right. You can see that we have two y's. One is here and the other one is there, which means that to get partial z, partial y is going to be sum of two terms. Okay, sum of two terms. Okay, the first term, let's go to this first branch of y. So to get from z to that y here, this z to that y, it has to go through u. So we have the first term is partial z, partial u times partial u, partial y. So from this u to that y, we have partial u, partial y. And then for the second branch of y, you have to go, this z has to go through v first. So the second term would be partial z, partial v, and then partial v, partial y, which is this one. Okay, all right, so you don't have to memorize the formula. So you just form a tree diagram, and from the tree diagram you would be able to know how many terms you should have to find partial z, partial x, and partial z, partial y. Okay, now let's look at an example. Okay, for this example, we're given a function. It says by using the chain rules, meaning that you can find out your answer without using the chain rule, but it says here by using the chain rule, find partial z, partial y, and partial z, partial x. Okay, if z is, so here we have z is u squared plus v squared, u is x squared y, and v is x squared cos y. So this is this function is given specifically in the theorem here, is given as f of uv. So you can see here we can form a tree diagram. So we start from z, and here we have a function in terms of u and v. So branch out to u and v, and u here is a function of x and y, so x and y, and v here is a function of x and y. So in the tree diagram you can see that we have two independent variables and two intermediate variable. Okay, to get partial z, partial x, as you can see, we have two x's here, 1, 2. Okay, to get to the first branch, we have to go through u first. So this is partial z, partial u, and then from u to x, partial u, partial x. And the second term is partial z, partial v, times partial v, partial x. Okay, now from the formula we can get partial z, partial u. So because this is our z, okay, z is u squared plus v squared. So we can get what is partial z, partial u. Okay, so partial z, partial u, differentiate z here with respect to u, holding v as a constant, so you get 2u. And we also need partial u, partial x. So this is u, so partial u, partial x. Differentiate u with respect to x by holding y as a constant, so you have 2xy. We also need partial z, partial v. Okay, so for partial z, partial v, going back to this function again, but now we hold u as a constant, so we have 2v. And we also need partial v, partial x. So this is our v. To get partial v, partial x, we hold y as a constant, so cos y remains as cos y. Differentiate x squared, we get 2x. So we have 2x cos y. And now we're going to put everything together. So the first term is partial z, partial u, which is 2u, multiply with partial u, partial x, which is 2xy, plus the second term we have partial z, partial v, which is 2v, and partial v partial x, which is 2x cos y. So simplify this, we get 4uxy plus 4vx cos y. And then of course the last step is to replace all the intermediate variables. So in this case, the intermediate variables are u and v in terms of the independent variables, which are x and y. So we have 4u, so u will be replaced by x squared y, and here we have xy, plus 4v, so that v there will be replaced by x squared cos y, and we also have x cos y. Okay, and then simplify it even further, we have 4x cubed y squared plus 4x cubed cos square y. Okay, so that is partial z partial x. Okay, alright, so for partial z partial y, we're gonna solve that in the live video. Sorry, live class. Thank you.